is a beautiful evening when I'm filming right now. Whenever you're watching it might be 9 o'clock in the morning. So right now, on Tuesday, about 7, it's gorgeous outside. Besides for that guy. Anyway. And, just enjoy the evening. And what better way to do that than to give a brief history of how electricity was discovered and came to be named and used and stuff like that, as one does on a beautiful Tuesday evening, such as it is right now. So let's go back. Let's go way back. And we start our story today in the ancient Babylonian times. See, very close to Baghdad, there was this archaeological dig that they did, and they found, deep underground, they found these jars. And these jars look suspiciously like a modern battery. They had an iron core, they had a little seal on the top, they had a little, on the bottom, they had a copper disc, and they found residue of this weird chemicals. And the only thing they could possibly think of what this could possibly be was this was an ancient battery. Now, hold on one second. I thought electricity was a modern invention. First of all, as we've established in the second lesson of lightning, no one invented it. It's a natural phenomenon made by God. But I thought it was a modern thing. I thought this was a modern thing that people use electricity. I didn't realize it went back thousands of years. You're surprised. So was I. But hey, that's what science is all about, isn't it? Originally, the first people to discover the idea of electricity at all, there were these ancient Greek children, and they noticed that if you rub fur on amber, it sticks to the fur sticks to the amber. They didn't know what this was. They didn't know what to call it. But that's what they observed. We don't have any historical basis for this, but a certain 6th grade science teachers speculate that there was a fair amount of ancient Greek wine involved in this discovery, but that's my speculation. I don't actually know, and I don't think anyone actually knows the circumstances that led people to write down and have as a recorded historical fact that that's what happened, but somebody did. So they noticed this and they didn't really know what it was, but since then it has been discovered that the ancients used electricity in making of jewelry. And see, there's this technique that you can do if you take one metal and a second metal and stick them both in a cup of water. I have the cup here. Stick them in, and you then take a little clip and you attach it to either side of you run a current through this metal. Whatever direction the current is traveling, that metal will go and coat the other metal. It's called electroplating. Now, they very commonly do this. They do this to make jewelry. They have a cheap metal. They have silver. They run a current through it, and then the silver is electroplated onto the cheap metal, and you can then have your earrings or your necklace or whatever you want to have, but it's very thin layer of precious metal on it. They found jewelry that fits this description, and the only way they can possibly think of that it was made was using this technique known as electroplating. So we have significant evidence that the ancients had some kind of way of using electricity. But it wasn't really understood. It was definitely not understood. It was definitely not identified as what it was. They just realized that these things happened, and so they used them. Similar to how since the beginning of time, people have used gravity, even though they didn't know what it was up until very recently in the span of things. They still used it anyway. No one flew off into space just because they didn't understand it. Similarly, they use this power, they use this electrical current to do things many thousands of years ago. Similarly, there was another story that someone had this lamp that would never go out, and people would come from miles around and be astounded by this lamp that would never go out. And so historians speculate that this was actually an arc light. What it is basically is an electric current that's arcing, which it's jumping through the air and generates light. But all of these things aside, let's talk about the modern era. And when it comes to the modern era, so we're already way behind in discovering it. Discovery happened about 2,500 years ago in ancient Greece with the amber. So in the 1600s, there was a scientist by the name of William Gilbert, and he was a doctor. First of all, he had his MD from Cambridge University, very fancy. Or I think in those days, pretty much that's it in terms of universities. He was this doctor, and he had a lot of experiments. He did things with magnetism, like remember we talked about in September how the Earth's core is made out of iron. That was his idea. He came up with this. I mean, God did it, but he came up with the idea that maybe that's what it is. Until then, people thought there was this big magnetic island up in the North Pole that all the compasses are being pulled towards, or they thought there was this that the North Star might be influencing the magnets, pulling the magnets or something. He came up with the idea that no, in fact, it is the Earth's core. He demonstrated this with various. He had made a model of the Earth. He basically had a metal ball in the center, a magnetized ball in the center, and he proved that was in fact the case. But he also did something else. He also using amber and fur, what you do, rubbing against various things, and he had a lot of arguments with the great scientific leaders of his time in regards specifically to electricity. But before we talk about why he called electricity, we must go to a segment that I like to call Rabbi Schiffman's Latin Lessons. Hello everyone, and welcome to Rabbi Schiffman's Latin Lessons, and today we're actually not talking about Latin, we're talking about ancient Greek. There is a single ancient Greek word for you to learn today, and that is electron. With a K, not with a C. Electron means amber. Remember we talked about how the ancient Greeks discovered static electricity. They didn't really know what it was, but they rubbed fur against amber. Well, amber is called electron. So now you know what amber is in ancient Greek. Let's get back to our lesson. So there you have, in fact, not the Latin, but the ancient Greek word for amber is electron. So he actually he called the force Electrios. Now he had a colleague, and his colleague's name was Thomas Brown, Brown with an E. And he was trying to explain this to someone else, and he called it's electricity was the word he used, and that stuck. And that is the word, he also called it electrios, because it's a lot more fun to say, but the word electricity was born with Thomas Brown, and that is the word we have to this day. Now, William Gilbert did a lot of things for electricity. He named it, but from there was a lot of other great inventors and scientists who figured out a lot of things along the way. For instance, we talked about negative and positive sides, how we have electrons and protons, and you learned about all the people who learned about the atom, who figured out those things. But the idea that electricity itself has a negative and a positive poles came from, if you remember, Benjamin Franklin with his experiments of the lightning. There are also a variety of other people who also came up with furthering the cause of science. There's Michael Faraday, who came up with the Faraday cage, among others, but also came up with the way of generating electricity. There was Nikola Tesla, who also advanced things vastly, alternating current, and Thomas Edison. All of these people greatly advanced electricity, but what we end up having is like this. Electricity, as we said. So the electrons are electricity, and whenever you see a flow of electricity, that is the flow of electrons moving through something. The first lesson of lightning is electrons. That's all it is. Now, the flow of electricity is electrons moving from a place of a lot of electrons to a place of a little electrons. We call that moving from the negative to the positive. Now, originally they thought it was the other way around. It was the positive to the negative, but they realized eventually that all the mathematical equations that they had made based on that it's the positive to the negative instead of the negative to the positive, doesn't matter because it's the same thing, it just mirrored. So, the truth being is that when you plug in a battery, electrons are coming out of the negative side, and going around, coming back in the positive side. Why are they leaving the negative side? Good question. I will tell you. They're actually getting pulled by the positive side. The positive attracts the negative. The area that's lacking electrons wants them back. The area that is too much wants to give them away. So, when you make a connection, or as we're going to learn about tomorrow, what we call a circuit, the electrons in the big, dense, negative area leave that area. They travel through whatever it is. They push past your... They push past your resistors, whatever's resisting it. It might be a light bulb, it might be a motor, whatever it is. And it goes and it keeps going, and it goes all the way back to the positive side. Now, eventually, that's going to even out, and your batteries can be dead. But with rechargeable batteries, you have the option of reversing that process by adding more electrons to the negative bit. But let's hold off on batteries. We're going to learn all about batteries later on in the second segment of this unit. This is Unit 6. This is Segment 1, all about circuits and what electricity is in the first place. So anyway, that is it for today. I hope you enjoyed greatly. I hope you enjoyed this beautiful evening last week, when this video will be airing next Tuesday, so this Tuesday. Anyway, figure that one out. Stay safe. Where are these? These are great. Also, this one happens to be fun, but feel free to decorate your own. Otherwise, please send me a picture of your notes from today. Tomorrow, we're going to be breaking out that big bag of stuff, which you probably already have from the first yesterday, where I challenged you to light the light bulb. But if you did, good, please send me a photo of that. If you did not, that's okay. Tomorrow we're learning all about circuits and how to do that, how to amplify the power of your battery so you can do that better. All of that is to come, so stay tuned for tomorrow. Have a wonderful night. Thank you.